Thermodynamic processes. Okay, thermo means thermal heat, dynamics means is movable. Okay, it's the process that we know. So here there are two types of the thermal process. There is one is called isothermal process, other one is adiabatic process. Okay, so isothermal means the temperature remains constant. Okay, so temperature is equal to constant. For adiabatic process, temperature is not constant. So you can easily understand the two processes. Okay, in an ideal gas equation, PV equal to mu RT. Mu is called number of moles in the gas molecules. This is constant value. Numbers. R is called gas constant, is also constant. If T also constant in case of isothermal process, so right side will be all are constant. Okay, so we write as PV is equal to constant. Okay, so this is the formula for that isothermal process. Okay, for example, the we will draw the graph like this to understand easily. So volume taken in a x-axis, pressure in a y-axis is called PV diagram. We already saw this. Okay. In case of expansion means what? The volume will be increases. Volume is increases. Pressure will be decreases. So we get like this. No, this curve will there. Put a point here. Here point is B. So Pi then Vi. Here is what? Final pressure. Then final volume. Okay, so the arrow mark which indicates this meaning of what? Expansion. If T is constant, okay, here T is constant, this is the meaning of isothermal process. Okay, clear? So you can say this is called what? Isothermal expansion if T is constant. Okay, so here initial pressure and final pressure, initial volume. Okay, so we will write as Pi Vi. In case of the final point B, Pf into Vf. So all are equal, constant. Okay, so we get that the hyperbola like this. Okay, in these cases, what about that compression? Okay, so V in x-axis, pressure in a y-axis, V in x-axis. Okay, so initially pressure considering here, okay, say Pi comma Vi. So compression means what? Pressure is increases, volume will be decreases. So the point curve become like this. Okay, say this is A now, this is B. Here is final pressure, then final volume. Okay. General is called compression if the T is constant. If T is constant means can say this is meaning of isothermal compression. Okay, clear? In this isothermal process, okay, and the first law of thermodynamics become, okay, whereas the amount of energy equal to W. Okay, because here the T is constant. Okay, if T equal to constant means the internal energy du is also constant. Okay, so it become 0. So that the first law of thermodynamics become Q equal to W. That's called work done. Okay. Next we will see for the adiabatic process. Here I told T is not constant. Okay, so we'll write as the equation PV is equal to mu RT. Okay, whether mu are all constant, we put PV not equal to T. Okay, that is a mu RT. Okay, so PV is equal to mu RT is not a constant. So where is a constant means you put PV power gamma is equal to constant. It means here the temperature will be constant means temperature will be transferred from system to surroundings. or surrounded to systems, then only it will be constant, T will be constant. In these cases, temperature is not constant means temperature is not moving from system to surroundings or surrounding to systems. Okay, then only it will be not constant of the temperatures. Okay, clear? So we will write as PV gamma equal to constant, whereas gamma is called adiabatic component. Adiabatic exponent, its value is equal to Cp by Cv, and Cp is called what? Molar to the heat capacity at constant pressure, Cv is at constant volume. Okay, so in this graph you will considering the for expansion V in a x-axis, P in a y-axis. For expansion we write about pressure is decreased, volume will be increased. Okay, like this. Say A, point B, pressure is Pi, volume is Vi, pressure is Pf, volume is Vf. Okay, but we know T is not constant here, so put Ti. Then here is what? Tf. If T is increased, we have include means this is meaning of what? Adiabatic expansion. Okay, for compression, volume in a x-axis, pressure in a y-axis. This is a point here. For a compression, pressure is increases, volume will be decreases. You get like this. Say A, B here, initial pressure, initial volume, then initial temperature. Here, final pressure, final volume, then final temperature. Okay, it shows like this. It's meaning of what? Adiabatic compression. Okay, so the formula will write as, so what is the pressure at A means we write as Pi Vi, but T is not constant. Put power gamma is equal to the final Pf Vf gamma, okay, is equal to constant. Whereas actually means write Pi V equal to Pf Vf. Okay, so if T is not constant means we will write as the pressure here. So pressure will write as the multiple of volume divided here. So we will write as mu or T by V. Okay, so this is the pressure. So we have to apply that here. Okay, we know that what? PV gamma is equal to constant. So pressure will write as the thing mu or T by V, V gamma equal to constant. Okay, then V is power 1. Okay, so we'll write as this thing. It will come in the numerator become -1. So we'll write as V power gamma minus 1. Put the T here. With the mu or multiple come with divided here. So it is equal to constant by mu r. So T V of gamma minus 1 equal to constant by mu r. Okay. In case of initial mean put Ti Vi. Final means Tf Vf. Okay. Then we will write as the same thing in other form. T power gamma. Then P power 1 minus gamma is equal to constants. So all the three things 1, 2, 3 is all what equation for that adiabatic process. Okay.